this video, we're talking about how to find the roots of a quadratic equation when we have to complete the square and then find roots that are complex. So normally when we're given a quadratic equation, the first thing we want to do is make sure that our terms are in descending order, which means that we take the highest degree terms, or the terms with the largest exponents, and put them first, and then we take the terms with the smallest exponents and put them last, which means we have to reorder this as 3x squared minus x plus 5 equals 0. From here, we can see that we have just a regular trinomial, and we want to see if we can factor this into two binomials. But there's no combination of the factors 3 and 1 and 5 and 1 that'll get us to -1. So we can't factor this as usual. What we can do is see if we can complete the square. In order to complete the square, we need to make sure that the coefficient on our x squared term is 1, and currently the coefficient is 3, which means we need to divide through every term in this equation on both sides of the equal sign by 3 in order to get rid of this coefficient. So dividing through everything by 3, we'll get this 3 to cancel here, and we'll be left with x squared. Here we'll get minus 1 over 3 times x, and here we'll get plus 5/3 is equal to 0, because 0 divided by 3 is still 0. Now, as you know, to complete the square, what we'll do is we'll take the coefficient on our first degree x term, so where we have x to the first power, or just x, we'll take the coefficient, including any negative sign here, and we'll do -1/3 divided by 2, which is the same thing as -1/3 times 1/2. So we can either divide by 2 or multiply by 1/2. It's easier to multiply by 1/2 because we're starting with a fraction here. So multiplying by 1/2, what we're going to get is -1/6. Then we want to take this result and square it. When we square that, we're going to get a positive 1 over 36, which means 1 over 36 is the value that we want to add to both sides of the equation in order to complete the square here. So what we're going to get is x squared minus 1/3 x, and here's where we want to add our plus 1 over 36. So plus 1 over 36, this is going to be what we can find the perfect square of, and then we're going to have to say minus 1 over 36 plus 5/3 is equal to 0. Now, if we factor x squared minus 1/3 x plus 1 over 36, we're going to get the perfect square x minus 1/6 squared. We can find that by factoring, or we can just take this value here, -1/6 that we found earlier, and plug that in here, -1/6. But either way, we get quantity x minus 1/6 squared, and then here we need to find a common denominator between -1 over 36 and 5/3. Well, we'll multiply this 5/3 by 12 over 12 to get 36 in the denominator, and what we'll end up with then is -1 over 36 plus 60 over 36. That, of course, will be equal to 0. When we do 60 minus 1, we're going to get a positive 59. So this is going to be a positive 59 over 36. When we subtract 59 over 36 from both sides, we're going to get x minus 1/6 quantity squared is going to be equal to -59 over 36. Now remember, the whole purpose of this was to find the roots of the quadratic equation, and we completed the square. What we needed to do is solve for x in order to find the roots. So our next step in order to solve for x is going to be to take the square root of both sides. So we can take the square root of the left-hand side like this, and we can take the square root of the right-hand side. We just have to indicate that this is going to be positive or negative square root of -59 over 36. When we take the square root of the left-hand side, we get the square root and the square to cancel with one another, leaving us with just x minus 1 over 6. On the right-hand side here, we have plus or minus. Remember, when we take the square root of a fraction, we can take the square root of the numerator and denominator separately. So we'll get square root of -59 over square root of 36. Now here we know that the square root of 36 is going to be equal to 6, so we can go ahead and simplify that. The square root of -59 we can go ahead and say is the same thing as the square root of -1 times 59, right? We haven't changed the value at all because -1 times 59 is -59, so we're just saying the square root of -59 here. Now remember that when we have two values multiplied together inside of a square root, we can separate them into their own square roots. So the square root of -1 times 59 is the same thing as the square root of -1 times the square root of 59. And as we know here from working with complex and imaginary numbers, the imaginary number I is equal to the square root of -1. So we can go ahead and replace this value here with I, which means that after all that simplification, we're going to end up with x minus 1/6 is equal to positive or negative square root 59 times I, all divided by 6. Now in order to solve for x, we just go ahead and add 1/6 to both sides in order to get this -1/6 to cancel on the left. So we'll get x is equal to 1/6 plus or minus root 59 I over 6. And because we have a common denominator here, if we want to, we can go ahead and combine these fractions and get x is equal to 1 plus or minus square root 59 times I all over 6. And these are going to be the two roots of the quadratic equation. And of course, we notice that both of those roots involve the imaginary number I, which means that these are complex roots of the quadratic equation. If we want to write out these roots separately, we can say x is equal to 1 plus root 59 times I all over 6, and x equals 1 minus root 59 times I all over 6.